Hey everyone, and welcome back to my channel. Today we are talking, we are taking a deep dive into a technology that's rapidly transforming our world, the Internet of Things or IoT. You have definitely heard the buzz, but what does it really mean? How is it, how is it reshaping our daily lives, businesses, and societies? We will explore its core concepts and delve into its history, examine real world applications across diverse sectors, and discuss the critical challenges and exciting future trends. So, get ready for an insightful journey into this connected world. So, let's start with the fundamental question: what is Internet of Things? At its core, IoT involves connecting physical objects, things to the internet. This connectivity empowers these objects to collect data, exchange information, and perform actions. Often autonomously, think of it as extending the reach of the internet into the physical realm, enabling seamless interaction between people, processes, and things. Let's start with the introduction to Internet of Things. So, truly and to truly understand IoT, it's helpful to first look at its evolution. While the concept of connected devices has been around for decades, advancements in microelectronics, wireless communication, and cloud computing have fueled its explosive growth. We will briefly touch upon this history and then explore the profound impact of IoT. The numbers are staggering. By 2025, the number of connected IoT devices is projected to reach 75 billion. This exponential growth underscores IoT's transformative potential. We will illustrate this potential with the real world examples from smart homes that enhance comfort and energy efficiency to industrial IoT that optimizes manufacturing processes and supply chains. So, IoT is used in various sectors. It has various uses, and hence in today's video we will look upon all its history, its aspects, and its growing trends. So first, to start with, we will also have to look upon the core components of IoT. What does IoT comprise of? As you know that IoT means devices which are connected to internet, and Internet of Things also comprises of devices like mobile phones, laptops, and voice embedded voice assistants like Google Home, Alexa, etc. So first, to understand the core components of IoT, connectivity is a crucial element that enables IoT devices to communicate and exchange data. A multitude of connectivity options are available, each with its own strengths and weaknesses. We have Wi-Fi commonly used in home and office environments. Bluetooth ideal for short-range communication between devices. Cellular networks providing wide area connectivity for mobile IoT applications, and low power wide area networks designed for long range communication with minimal power consumption, suitable for applications like smart agriculture and asset tracking. Data processing is where the raw data is collected by sensors and is transformed into meaningful information. We will discuss edge computing, which involves processing data closer to the source of at the edge of the network. This approach reduces latency, conserves bandwidth, and enhances privacy. We will also cover cloud computing, where data is transmitted to remote servers for storage, processing, and analysis. Cloud computing offers scalability, powerful computing sources, and advanced analytics capabilities. The choice between edge and cloud computing depends upon specific requirements of the IoT application. The user interface is point of interaction between humans and IoT devices. UIs can take various forms, including mobile apps that provide convenient control and monitoring of IoT devices, dashboards and that visualize data and provide insights for decision making, and voice assistants that enable hands-free interaction with IoT devices through voice commands. The goal of UI is to make IoT systems accessible, intuitive and user friendly. So these core components of IoT, why they are important? Because these core components help the IoT to interact with the environment. It helps the IoT to interact with the customer or the consumer. For example, the sensors. What effect that they add? Sensors are basically used as are used in bringing information. They help the IoT devices to interact and to adapt to the real life environment. These sensors are used by robots and other AI devices. Connectivity. So Wi-Fi, Bluetooth and cellular network play an important role here, because IoT devices mean need a lot of internet connection and very good bandwidth. Bandwidth basically means the amount of data that is being transferred over the internet in a particular time unit, and it's basically measured in bits per second. And third is data processing. So what happens is that IoT devices need a very fast communication over the internet, and hence these IoT devices need edge computing and cloud computing, where the data is processed in the client's computer, and hence data is not transferred to any centralized cloud or any storage, which also helps in reducing the cost on the on the company's side, and also helps in reducing latency, means communication delay, on the client's side. And on the other hand, user interface. So let me give you an example. If anyone has visited that app Google Home, which is used to interact with Google Home, in that app it's user friendly. In that app you can connect to your nearest Google Home within seconds. Hence most of the users use that app instead of preferring other apps. Why? Because it's user friendly. There are many other apps in App Store, in Play Store, but specifically that app is used because it's user friendly, it saves time, and hence a user interface plays a major role in IoT. So now let's further understand IoT with the help of the architecture, which is a layered approach. So IoT systems are often structured in a layered architecture. The device layer, also known as the perception layer, comprises the sensors and actuators, along with embedded systems that control their operation. The network layer facilitates communication between devices and the cloud, handling data transmission, routing, and network management. Gateways play a crucial role in this layer, often acting as intermediaries between different communication protocols. The cloud layer or platform layer provides the infrastructure for data storage, processing, analytics, and application services. This layer is where data is analyzed, insights are generated, and decisions are made. Finally, the application layer is where the end user application resides, providing interfaces for user to interact with the IoT systems such as a smart home control panels, industrial monitoring dashboards, or healthcare management systems. Now, these are the four layers of IoT architecture, and hence this architecture is a bit complex, but it's important so that you can understand IoT. First is the device layer, second is the network layer, third is the cloud layer, and fourth is the application layer. So these four layers are together form the architecture of IoT. Now let's move on to the applications of IoT, which are which means that how IoT is used. It's used in smart homes, healthcare, manufacturing, and various other sectors. This is mainly done for automation and using artificial intelligence. So IoT is revolutionizing numerous sectors. In smart homes, IoT devices automate tasks, enhance comfort, improve energy efficiency, and provide security. Examples include smart lighting systems, smart thermostats, security cameras, and home automation hubs. In healthcare, IoT enables remote patient monitoring, wearable health trackers, smart medical devices, and improved healthcare delivery. These, these applications improve patient outcomes, reduce healthcare costs, and enhance the quality of life. In manufacturing, IoT derives digital transformation through predictive maintenance, asset tracking, supply chain optimization, and improved operational efficiency. Sensors monitor equipment health, predict potential failures, and enable proactive maintenance, minimizing downtime and maximizing productivity. So here we can basically understand the use of IoT in smart homes, healthcare, manufacturing, offices, and various other. So in smart homes, it is basically used for automation, such as there are autonomous fridges at this point of time which are being developed, with the help of which we can easily order food items which are not there in the fridge. Healthcare, so with the help of healthcare professionals can monitor the patient's heartbeat, sugar, pulse rate, etc., with the help of devices embedded on the patient's body, and hence the doctor or the healthcare professional can access this data from through internet. And manufacturing, so as you know that manufacturing, a lot of automation is happening, industrial robots are being made, and hence these manufacturing factories also need IoT, because as you know that in factories the production also goes on in the night, where the workers are not there. So hence, if the factory breaks down or any fire is there, so the IoT devices would help in informing the workers or the senior employees working in the factory about that fire. Hence, IoT also plays a major role in manufacturing. In offices, IoT is basically used for is also used for automation. Like, if I say, "Hey Google, print this page from this document from my laptop," I can simply print that page using Google Home, without just without following the steps. Like, first I will search the document, I will then I will click on that document, and then maybe a numerous processes. If you are working in office, there are certain security provisions, hence it becomes difficult for in offices to take a simple printout. So these are the applications on various sectors. IoT is also used in various smart cities. As in smart cities, it is used for lighting purposes. It is used for waste management, environmental monitoring, weather prediction, etc. So now let's start with it. IoT is also a key enabler of smart cities, creating more efficient, sustainable, and livable urban environments. Smart lighting systems use sensors to adjust street lighting based on real time conditions, reducing energy consumption and improving safety. Smart traffic management systems use sensors and data analytics to monitor traffic flow, optimize traffic signals, reduce congestion, and improve transportation efficiency. Smart waste management systems use sensors to monitor waste levels, optimize collection routes, and reduce environmental impact. Environmental monitoring systems deploy sensors to measure air and water quality, monitor pollution levels, and provide data for environmental protection and public health initiatives. These are just a few examples of how IoT is transforming urban landscapes. So these are the applications of IoT in smart world in smart cities. IoT has also various uses in autonomous cars. As in autonomous cars, these cars are not driven by a driver, and hence they need a large connectivity, and hence in IoT it can easily measure that what is the traffic flow, where is the traffic congestion, and how is the road, is it smooth or any type of work is going on the road. So hence with the help of IoT it becomes easy for autonomous cars also to communicate with the internet. As in IoT, cloud computing and edge computing are followed, with the help of which latency is reduced. IoT also faces a lot of security challenges, like the IoT devices have limited processing power and memory, making them vulnerable to security threats. Device vulnerabilities such as weak password, outdated software, and insecure configurations can be exploited by attackers. Data privacy is a major concern as IoT devices collect vast amount of personal data which must be protected from unauthorized access, use, or and disclosure. Network security is crucial as IoT devices and targets can be targets of cyber attacks such as denial of service attacks, which can be disrupt services and cause significant damage. The lack of standardization in IoT security creates challenge in implementing consistent and effective security measures across different devices and platforms. So now IoT also has major security challenges because IoT is so fast that sometimes the data is leaked in through various holes, and hence we need network security, data privacy, and device vulnerability and lack of standardization are the major security challenges in IoT. So now privacy considerations in IoT. Protecting privacy in IoT requires careful consideration of data collection, use, and management practices. Data minimization principles should be followed, collecting only the data that is strictly necessary for the intended purpose. Transparency is crucial, providing users with the clear and concise information about how their data is being collected, used, and shared. User control over his data User control over their data should be empowered, allowing users to access, modify, and delete their data and to control data sharing preferences. Anonymization techniques should be employed to remove or obscure identifying information from data, protecting individual privacy. Privacy preserving technologies and practices are essential to build trust and ensure responsible use of IoT. So now you can see that how IoT plays a major role. How can we make IoT secure? First is secure design, strong authentication, encryption, regular updates. So many of you use WhatsApp. So WhatsApp is basically a chatting software. When you chat with some person, on above your chat window you will also you will find something written, you will find a dialog box where it is written in end to end encrypt. What does it mean? It basically means that when the data is being when the data when you when you write something on WhatsApp, it's then converted into a unreadable form. This is called the process of encryption, and this leads into an encrypted file. This encrypted file is then transferred into a data packet, which is then transferred through the internet. And when it reaches its original position, it is converted into it is decrypted, and is converted again into a readable format, which can be then read by the person who is chatting. So now let's understand the future trends of IoT. The future of IoT is filled with exciting possibilities. The integration of AI and machine learning with enable predictive analytics, allowing IoT systems to anticipate future events, optimize operations, and make intelligent decisions. Edge computing will become increasingly important, enabling real-time processing of data at the edge of the network, reducing latency and supporting new applications that require low latency response. The rollout of 5G connectivity will provide faster speeds, lower latency, and increased capacity for IoT devices, enabling new applications and enhancing their performance of existing ones. These trends will drive further innovation and transform industries, creating new opportunities and shaping the future of connectivity. So these are the privacy consideration of these are the future trends of IoT. And now let's proceed with the conclusion. So IoT transforms industries, it provides opportunities for growth, addressing security is crucial. Embrace IoT and innovate responsibly, shape the future of connectivity together. So the future in the future, it's important to protect IoT, for that IoT is being used only for innovative purposes and is not used for making for spreading viruses through Khan horses, malware, because these things may affect the you may affect other may affect the future trends of IoT, and hence it's very important to maintain a cyber security cell of the country, and hence we should always try that we are not following unethical practices. Hence it may lead to it may lead to spreading of Turkhan horses, viruses, etc. And thank you for joining for watching this video. Please like this video and subscribe my channel. Thank you.